वेलकम बैक। लास्ट लेक्चर में हमने देखा था कि एक स्प्रिंग कैसे बिहेव करता है इन रिस्पॉन्स टू एन एक्सटर्नल फोर्स। इन दिस लेक्चर वी विल स्टडी अबाउट वर्क डन बाय दैट स्प्रिंग फोर्स। So before we begin, we need to take into consideration two assumptions. Why do we need to take those assumptions in our hand? Okay, these assumptions will make our calculations very easier. If you are not taking those assumptions, then we will have to take into consideration a lot of parameters that would make our complication very complex, and that needs to be avoided. That's why we are taking those assumptions. Here we go. The first one is mass of the spring is negligible as compared to block. As can be seen here, a block has been connected to a spring in such a way that the mass of the spring is very less as compared to the block, and hence we can ignore the mass of the spring as compared to block. And the second one is this spring obeys Hooke's law. So let's get started with the work done. We have seen that a normal work done by a normal force F is equal to F vector, that force vector, dot product of displacement vector. That comes out to be F vector magnitude, D vector magnitude, and cos phi, where phi is nothing but the angle between F vector and D vector. But remember, we have causes ourselves with one thing here, that force must be constant in this equation. Force must be constant. If force is constant, then only we will be able to apply this formula. Okay, so it is nothing but work done by any general force F, which is equal to dot product of F vector dot displacement vector, and hence we need to find out work done by the spring force. So that should be equal to the force of spring force dot product of spring force and displacement it causes. But can we really use this formula? No, because we have seen that force must be constant. But here, is spring force constant? No. As per Hooke's law, we know that spring force is equal to minus kx. So spring force varies as per the coordinate x. Okay, so Fs is a dependent quantity, so it is not constant. And since it is not constant, we won't be able to use this formula. Okay, so there must be a middle path between the two. Can we use this formula? Can we use this formula too? For the moment, no, we cannot use, because force is not constant. So let's do something which makes this force constant. As we can see here in the diagram, an external force is getting applied on this block, due to which the block changes its position from x initial to x final. Okay, and this is nothing but spring force, which is always acting towards rightward direction, opposite to F external. Okay, so we have taken the screenshot of the motion of this block when it crosses a position x. That screenshot has been shown here. Okay, so we are simply making a choice of taking a screenshot of this entire system when this entire system was crossing a coordinate x. Why we are actually doing so? Okay, we are trying to examine the motion of this entire system when this system crosses coordinate x. Okay, when this block is at position x, there must be some spring force acting on this block. Let's consider that spring force as Fsx. X represents Fs represents a spring force and x represents the coordinate. It shows force, spring force at the coordinate x. Okay, x is the coordinate. Let's consider the motion of the block when this block changes its position from x to x minus dx. Okay, it is moving towards left. That's why we are considering the motion of this block in the leftward direction. And let's consider the motion, let's analyze the motion when this block moves from x to x minus dx. As we know that dx is a very small quantity, that is, it is infinitesimally small quantity. Here x is very small, that is dx. And since it is very small, the variation of spring force in this interval will be very low. So we can say that in this interval, that is in this displacement of dx, fx must be constant. Okay, and that is equal to minus k of x. Okay, so what we are doing is, since fs is a variable force, we are restricting our analysis only to the interval of dx. If we are restricting our motion of this block in this interval of dx, then we can consider the force, spring force, to be constant in this interval. Okay, so for this interval, for interval dx, we will analyze the motion of the block. We will analyze the motion of the block. And why we are doing so? We are doing this only to make sure that the spring force, which is variable of x, becomes constant. And if it becomes constant, then we can happily utilize this equation, fs is equal to fs vector dot d vector. So let's proceed further in next section. Okay.